Okay, so before we go to next chapter, let us do a combined concept problem. So this is mechanics and electrostatic combined together, and this is chapter 18, problem number 60. Problem 60, and page 663. In the book, you will see that there's a picture given. The picture has a ceiling, and there is a mass M object hanging at an angle theta, and that theta is given as 8 degrees. Alright? And the length L of this cord, L is 30 centimeters. We will find that you don't need to use this. Mass M of this object is 5 grams. And electric charge on this object is 10 microcoulombs. And the reason that is hanging to the right is because there is a force pulling this object to the right. And the force is coming from electric field. I am not going to draw electric field all over the place because then it will confuse you. It will be confusing looking. So I'll just draw it on this side. You have to understand that it's going all the way horizontally across this plane. Okay? So that's electric field E. So now there is force on this object. There are forces on this object. That one is obviously gravity. So that's mg. I'll just draw write the magnitude. So the force of gravity is F gravity. Magnitude is just mg. Okay? Then there are other forces on this object. That is the tension T in this rope. Alright? So now I have to draw a little arrow here, and I draw a tension T here. So that tension T is directed in that direction. Now, that tension T, I'm going to decompose it into two parts, X component and Y component. The reason is because if we take the origin of our coordinate system at this object, this is X axis, this is Y axis, then this T is not on X axis nor on Y axis, so that means we have to decompose it. But the gravitational force is already on Y-axis, is pointing down, so I don't have to decompose this mg any further. Alright, so let me draw a little coordinate system here. Alright, so now this tension I'm going to decompose it into Tx and Ty. Alright. Now there is one more force that is on this object, because this object has charge Q, and since it's moved hanging to the right, that means there is a force pushing it to the right, and it's coming from the electric field, and that electric field is exerting a force E electric on this object. The magnitude is given by magnitude of the electric field. Sorry, this is F, not E. F electric is E times Q, the charge, right? So obviously there are four forces now. One is the tension Tx pulling to the left, tension Ty pulling up. These are the components of a tension T. Once you decompose it into Tx and Ty, you do not have to think about T anymore. Okay? and then gravity is pulling it down, it's mg, and the force pulling to the right is coming from electric field, and the magnitude is given by EQ. So now when an object is not moving left nor right, that means forces pulling to the left must be equal to forces pulling to the right. And it's not moving up and down, then forces pulling up must be equal to forces pulling down. That's what we learned from mechanics, right? Or common sense. All right, now this F force pulling to the left is obviously tangent Tx and must be equal to forces pulling to the right, which is F electric. Okay, so we go down one step further, then Tx is the component of T in the negative x direction, that is T, this is theta, so this must be the opposite, so then Tx is T sine theta. Okay, and F electric is, as we know now, it's E, magnitude of E times Q. Okay, now that is from forces pulling to the left is equal to forces pulling to the right. Now what about this one? Forces pulling up. Forces pulling up is Ty, and forces pulling down is force of gravity. And Ty is T cosine theta. Okay, because this is theta, then you can see that this angle is also theta. This is T, so this is T cosine theta. And F gravity is just mg. So now we have two equations. One is from forces pulling to the left and forces pulling to the right. One is from forces pulling up is equal to forces pulling down. So now this is equal to this and this is equal to that. So I'm going to divide T sine theta by T cosine theta. Then obviously on this side, T sine theta is equal to EQ and T cosine theta is equal to mg. Alright, so I can divide these two equations. So then T and T cancel out. Sine and cosine, sine theta divided by cosine theta is tangent theta. And this is E magnitude Q by mg. Okay, so that's our final formula. From there I can find E. So don't put numbers before you substitute, before you find what you want. So E is equal to electric field E is equal to mg times tangent theta by Q. Okay, mg times tangent theta by Q. So m is 5 times 10 to the power minus 3 kilogram, because in 1 kilogram there are 1000 grams, and G is 9.8 meter per second squared. Tangent theta has no units, just tangent 8 degrees. Divided by Q is 5 times 10 to the power, 10 times 10 to the power minus 6 coulombs. So kilogram meter per second squared, that's newtons, and the unit will come out with newtons per coulomb, which is correct for electric field. All right, so let's do that calculation, and that is, I don't know if you can see it, but that's 5 times 9.8 times tangent 8 degrees is equal to 6.88 times, I just multiplied 5 and 9.8 and tangent 8 degrees, and then this is 10 to the power minus 3 divided by 10 to the power negative 6 newtons per coulomb. Sorry, 10, there's a 10 here, so 10 to the negative 5 newtons per coulomb. So the answer is 6.88 times 10 to the power positive 2 newtons per coulomb. So it is 688 newtons per coulomb. All right? So it is 688 newtons per coulomb. All right? Okay.